A fraction of a degree in Mercury's orbit pushed astronomy into one of the most expensive mistakes in scientific history. By the late 1800s, the most trusted equation on Earth had stopped working. Astronomers tracking Mercury noticed something deeply wrong. The planet was drifting ahead of where Isaac Newton's laws said it should be. Not by much, just 43 arcseconds per century. Tiny, almost invisible. But that tiny error carried a terrifying implication. If Newtonian gravity was wrong, then the entire mathematical system used to predict the motion of planets, comets, and the structure of the solar system itself might be incomplete. And nobody was willing to accept that. So instead, the world decided reality had to be hiding something. In 1859, French mathematician Urbain Le Verrier published what seemed like the perfect solution. He was not an ordinary astronomer. Just 13 years earlier, he had predicted the exact location of Neptune using mathematics alone. And he had been right. Now Le Verrier announced Mercury was being disturbed by another hidden world, a planet inside Mercury's orbit. He named it Vulcan. Suddenly, observatories across Europe turned toward the sun. The search had begun. At first, everything looked convincing. Astronomers repeatedly reported seeing tiny black dots crossing the face of the sun, exactly where Vulcan was supposed to appear. Reports flooded scientific journals. Some described a dark, circular object moving slowly near the solar edge. Others claimed multiple sightings years apart. Each observation seemed to confirm Le Verrier's calculations. Inside elegant stone observatories, giant brass telescopes projected detailed maps of the solar system. And somewhere near the blinding edge of the sun, a tiny black dot labeled Vulcan quietly entered astronomy textbooks. But something had already started separating from expectation. The sightings never matched. Different observatories reported different orbital periods, different sizes, different transit durations. Some astronomers saw Vulcan repeatedly. Others saw absolutely nothing. That should have been enough to trigger doubt. It did not. Because the calculations came from Le Verrier, and more dangerously, the calculations protected something even bigger. Isaac Newton. Newtonian mechanics had become the operating system of science itself. Engineers trusted it. Naval navigation depended on it. Planetary predictions across the entire scientific world relied on its equations staying intact. If Mercury's orbit could not be explained, then gravity itself might need rewriting. And that possibility felt far worse than inventing another planet. So Vulcan survived. Then, the problem became bigger than Mercury. Over the next several decades, astronomers kept forcing new observations to fit the prediction. New solar transits were announced. Amateur observers joined the hunt. Mathematical revisions tried adjusting Vulcan's mass, orbital distance, and speed. Each correction created another contradiction. The tiny black dot near the sun kept returning, but never consistently enough to exist. The first explanation had worked, until one detail refused to fit. Mercury kept drifting. Even after accounting for Vulcan, that changed everything. Now the problem was no longer about finding a hidden planet. The problem was the entire predictive engine of astronomy itself. For nearly 50 years, scientific institutions kept defending a solution reality refused to validate. Observatory walls still displayed beautiful diagrams of the solar system. The same diagrams now carried an invisible flaw. That tiny black dot near the sun no longer represented discovery. It represented institutional dependence. Astronomy had become trapped protecting its own assumptions. And then, a 26-year-old patent clerk in Switzerland quietly entered the story. In 1915, Albert Einstein published his work on general relativity. His equations describe gravity differently. Not as an invisible force pulling objects together, but as the curvature of space itself. And when Einstein applied those equations to Mercury's orbit, something extraordinary happened. The anomaly disappeared instantly. The exact 43 arcseconds per century. Perfect match. No hidden planet. No Vulcan. No mysterious solar object waiting to be discovered. For half a century, the greatest scientific institutions on Earth had defended something that never existed. Not because their observations were careless. Not because their instruments failed. Because the foundation underneath their thinking felt too important to question. And suddenly those grand 19th century observatories looked different. The same projected solar system diagrams remained on the walls. The same tiny black dot labeled Vulcan still sat near the sun. But now it meant something else entirely. It was evidence that science does not always fail when data is wrong. Sometimes entire generations of experts become trapped defending false reality because one small contradiction threatens everything underneath it. Mercury never changed. The equations did. And for 50 years, humanity searched the sky for a planet created by its own certainty. Sometimes the most dangerous mistake is trusting what already works.